Hello students, I am Sachin Prakash and I teach and mentor students in chemistry for IIT. I believe that the real confidence which is required to crack this IIT exam will come only when you are confident in tackling good problems. And that clarity and understanding of concepts will only develop when you are really comfortable in handling these problems. So this video contains the paper discussion which I have conducted in my uh, classes online. Okay, and a lot of good doubts are there which I have discussed here. It will be helping you people in understanding, developing an understanding in how to approach and tackle good problems. Okay, and if you like this, if you found this paper discussion video to be useful and interesting, you can, like, comment, and subscribe to this channel, which will surely, motivate me to add some more useful videos of this type. Okay, because ultimately it's this is just an effort, honest effort, small honest effort from my side to help the student, uh, help my students as well as other students also in their ITJ preparation. So let us begin with this paper discussion. Okay.
Okay, so now we are live, and today we are going to discuss WTM 19. Okay, so this paper is based on acid GOC final part, which is acidity and acidity, and it is also based on tautomerism. So these two topics are covered in this paper. So this is a paper in front of you. Okay, so it's on the main pattern, and these are the questions. Okay, so as usual, we'll be starting from a numerical value type because that is my favorite. Okay, so let us start 71 to 75. Any doubts?
75 different
It was
enols.
75.
75. There are two forms of acetyl acetone. Okay,
ఫ్యాన్ ఘోరంగా ఉన్నాయి.
one will be something like this, and another will be something like this. See, acetyl acetone is having two alpha types of alpha hydrogen. Okay, if you see the acetyl acetone, then it is having, it is a symmetrical molecule.
నాబాబు బిడ్డ
So you have H and HB. There is a lot of background noise. Okay, I'm just going to pause all of you. Okay. Now, is it clear? Yes or no? These are the two forms. H and HB.
We can convert other one also into enol, sir.
Yes, sir.
Which one?
Like
Yes,
other
sir.
C double
Other-
bond.
No, dienol. They are not. That will be en diol, like en diol, not enol.
Then it will be a type of enol. I mean double bond
See,
and
what do you mean enol?
One enol.
There should be one alcoholic group. This is en. It's diol actually. Are you getting a point?
Yes, sir.
Okay.
yes, sir.
Okay. So this is done. After this, next one.
Sir, 72 H2O, sir.
72. 72 answer should be 5 only, 4 only. You see, I have told you that negative charge will be more stable on the highly electronegative atom. Okay. So if you are having like so you see, I have told that oxygen, the electronegative order is fluorine greater than oxygen, then sp carbon, then nitrogen, then sp2 carbon, then sp3 carbon, right?
Yes, sir.
So just remove H plus and see the stability of carbon ion. So Answer should be H2OHF, CH3CH2OH, and CH3CH2SH. Okay, this is electronegativity order across the period. Down the group, bigger negative charge is more stable on a bigger atom. Are you getting a point? So CH3, CH2, S minus. This will be more stable than CH3, CH2, O minus. Are you getting my point?
Yes, sir. Understood.
Okay. After this, next
74 2
74 second option.
Sir, 74 second one.
Option is possible, no, sir.
The second option, you will be having something like this. It will be having an in diol again. Are you getting a point? Yes or no?
Yes, sir.
So this will be stable, but enol won't be greater than keto. This,
Sir,
yeah.
sir, we can also think like there's already hydrogen bonding in the keto form, right?
In enol form.
See, hydrogen bonding is there in both. See, in alpha diketone, the stability is due to two factors. Beta diketone. You see, if I'm trying this one, the stability is both because of conjugation of this pi bond with double bond O as well as the intramolecular hydrogen bond. That is why enol is greater than keto here. Are you getting a point? I think I've given the data also in the notes, no?
Yes, sir. In before case.
Yes, sir.
In this case, you are still having a keto form here. Okay, see, if there's single keto group, then enol will never be stable. Are you getting my point? Just make it a rule.
Sir, in first and second, both are stabilized by resonance. But in first, it is more stabilized by double bond.
See, first of all, in first case, so you can't have any enol form.
Yes, sir.
Yes,
There is
sir.
no alpha hydrogen. Second case, you are having enol form will be relatively stable, but it won't be as stable as it won't be more stable than a keto form. Why? Because here keto form is also resonance stabilized. Are you getting a point? So there is no reason why enol should be preferred over keto here.
Yes, sir.
Okay.
Okay,
In other cases, so you know the things. Okay.
yes, sir.
So here you should remember that enol is more than keto because two factors are there. Conjugation carbonyl
H.
plus intra
Hydrogen.
S bonding. Okay, so 75 is done. Okay, so I think all the questions here has been discussed. 71 should not be a doubt.
No, sir.
No, sir.
73,
No, sir.
I think we have discussed better questions than this. Okay, so 67 to 70. 67 to 70.
No doubt, sir.
No doubt.
70 one say no, sir.
Sir, 69, why not?
Yeah, we'll discuss both. First 70. You see, again, negative charge is more stable on a higher electronegative atom. So it is less stable on a lower electronegative atom. So that atom will be more basic. Yes or no?
Yes, sir.
So in both cases, it is on sp3 carbon. Here it is on oxygen. Here it is on a sp2 carbon. So the best candidates are sp3 carbon only because they are less electronegative. They can't handle the negative charge, so they will be reactive. Yes or no?
Yes, sir.
Yes, sir.
But in 3, the charge is delocalized. In 2, it is localized. So, sorry, in 4, it is localized. So, answer should be 4.
Yes, sir.
Okay.
Yes, sir.
So, after that, 69. Yeah, what is the doubt in 69?
Sir,
Why
we
can't it be
draw
option 2, sir?
Yes,
Option
sir.
2 cannot be, because you see, phenol will be existing in the form of what is as
Aromatic.
aromatic form only. It doesn't have its keto content is negligible. actually.
Sir,
Sir,
but
but still it's
whether it
exhibiting, right?
exhibits the auto. Yes, sir.
We can write or not, we have to check, no, sir. Like, how will we know the data?
Yeah, that is the thing. Okay, we can ask for 2 also. Okay.
Sir, but
Yes, sir. Thank you.
automatic stabilization,
Need
it
to
can't
select for
be like-
best option.
No,
For
see,
aromatic.
no, you see, it's not about aromatic also. You see, the thing is that her point is correct. Can you write a tautomeric structure, valid tautomeric structure for phenol? The answer is yes.
Yes, sir.
Okay. If we can't write, then there's no issue. But we can write now. Even if it is 99.999999.0000001% will be might be there in non-aromatic form. Getting a point?
Yes, sir.
So
Yes, sir.
phenol should be there, should also be an option. Okay. After this 68, so 69 has to be key correction. Okay, 68.
No,
Yeah.
sir.
The
No
67
doubt, sir.
option 2, sir. Like what would be the order?
67.
Option 2, sir. Like what would be the order? Second option.
Okay, 67, the order should be reversed actually.
PK.
But I have to check the values actually. Actually, both HClO4 and H2SO4 are very strong. Like,
HClO4 is strongest.
yeah, let me just uh, see, as per the resonance, HClO4 is having pK of -8. Okay, so at this level, pK loses its relevance, but still we are right. And H2SO4 is having a pK of -3. So HClO4 is more acidic. The reason behind the acidity is that, ClO4 minus, this negative charge can be delocalized here, here, and here. Are you getting a point? In SO4, 2 minus, it can be, see, if you are talking about the first pK, then it can only be delocalized to 3 atoms. Are you getting a point?
Yes, sir.
In case of NO3 minus, sorry,
Sir,
yeah.
sir, all these are mineral acids, right, sir?
Yeah, the concept of pK is not very much valid here, but still, all the pK, they will be having negative pK values only. Are you getting a point?
Sir,
Yes, sir.
once can you say order for
The
options
order is, this
2,
is the
3, and
order
4?
of acidity actually. Is it clear?
So for remaining 2 options also, can you say?
Remaining 2 options. Again, when you're talking about OCl minus, OF minus, OBr minus, and OI minus. So just I have to check one. Okay. HOF pK. Sure. So order will be like, in this case, it should be HOF greater than HOCl greater than HOVr greater than HI. Yeah, this should be the order.
So is it databased?
Yeah, that is what I'm trying to.
So let's go to say PK values.
pK values. Just 1 minute. Mm, Somewhere the data should be there. Data I'm not getting for this. Hmm. Hmm. Acidity HF, pK is not given. Acidic strength and molecular structure. Actually, for mineral acids, the data is not available that easily. Okay, HOCl is having a pK of 7.5, HOBr 8.6, HOI is 10.6, but HOF not given.
Sir,
Yeah, the order should be this only. This HOF is most acidic.
because
Okay.
electronegativity of the
Electronegativity.
Yeah, here electronegativity of in the minus I effect of fluorine is stabilizing the anion most.
Yes, sir.
Okay, in this case, H2O2 is more acidic than this. Sorry, R is ET. No, this is wrong. In this case, H2O2 is more acidic. All water is acidic than ETOH. This is the order of acidity.
Sir, between H2O2 and H2O.
You see, if you're talking about the anion, you are having this, you are having this. This will be stabilizing it through minus I effect. Is it clear?
Yes, sir.
Sir,
Okay.
Sir, in case of HOF, HOCl, that case,
Yeah.
we can consider back bonding
Yes,
stabilization
that is
also,
the
no, sir?
thing. That is the thing. You see, fluorine is highly electronegative. Okay. And here, chlorine is having back bonding stabilization. But you see, when you're talking OCl minus, I'm telling you why technically it is possible. I'm not saying it is not possible. But suppose it is, there are three lone pairs from 3p lone pairs from chlorine, which will oppose the back bonding of oxygen. Are you getting back bonding is more favored when lone pair is going to a positively charged orbital. Are you getting my point? Where there are already lot of lone pairs, the back bonding will not be that effective. Are you getting my point? But still, it is possibility here. So here we have to check the values. Are you getting my point? There's no
Yes,
other
sir.
way of saying it. Okay.
That means chlorine back bonding will not always make it more acidic.
Yeah. See, I told you, in acidity and basicity, trends are totally data-based. Okay. Okay. Wherever there is a clash of two effects, we have to consult the data to see which effect is actually predominating. Is it clear? Yes or no?
Yes, sir.
That is very good.
Sir,
Yeah, tell me.
So for
so
option
again, can you explain that ClO4 minus that one?
This one, third.
The
second,
first one. I mean the second option.
Second option, the resonance is more in case of chlorate, then sulfate, then nitrate, and finally NO2 minus will have the least resonance. Are you getting my
Okay,
point?
sir. Yeah, okay, sir.
That's it. So 67 is done. 66 should not be a doubt. Or is it a doubt? No doubt. That's good. 65, 4.
Explain, sir. 65.
Yeah.
65.
Just because it is a boron, you people are asking this question, no? Other than that, there was no reason for asking this question. Am I correct? Yes, no? Tell me. See,
Yes, sir.
even if I am changing the
Yes.
atoms, the basic principles of organic chemistry remain the same. You have to just check. Okay, acidic strength is what? The acidic strength of the vacant p orbital of boron. Yes or no?
Yes, sir.
So that way, if it is getting filled, then the acidic strength will be less. If it is not getting filled, the acidic strength will be more. Yes, no.
Yes, sir.
Yes, sir.
Now you see OH is common in all the cases, so we are cancelling out the effect of OH. Are you getting a point?
Yes, sir.
So
Yes,
now we
sir.
have to just see the ring. In ring, OET minus at this position will be creating a negative charge here due to plus M and a positive charge due to minus I. Are you getting a point? But plus M will be
Sir?
dominating.
Yes, sir.
But
Ortho effect is also there, no, sir?
Huh?
Ortho
Okay.
effect.
So when we discuss ortho effect, what did I tell you people?
only
It's
for
only for benzoic acid and
Aniline, right? And then I also told this it is not even applicable for phenols also.
Yes, sir.
Yes, sir.
Okay, so it won't be applicable here also. Okay, so apart from that, okay, you are having OET minus here will be only creating a positive charge here, and here it will be net creating plus M, but means negative charge. But here the plus M will be here the minus I will be less. Only plus M is there. Here plus M and minus I. So here the negative charge will be more. The boron will be stabilized more in this case. So its acidity will be less. Okay. So the acidity will be maximum in case of 2 because there is a positive charge which will be amplifying the electron deficiency of boron. Then second will be 1 and then 3. Is it clear?
Sir,
Yeah.
Sir,
Sir,
in one
in
there is
first
more
one,
percent, sir. Then it should
It
be
can go
lesser.
out of plane, sir.
out of plane.
See, we have discussed that the ortho effect is only in these two cases. I haven't
Not
seen
other effects,
But
sir.
it can
Steel.
go out of plane, sir.
It can go out of plane, no, sir.
The steric
see,
inhibition of resonance.
even if it goes out of plane, let us say it goes out of plane. Okay. Let us
Plus
say
some
that,
effect will be.
yeah, plus some effect.
Not valid.
Then it becomes
That
very
p orbital
different.
will go out of plane means no effect of plus some effect will be.
Yeah, that is the thing. But I haven't seen a case of steric inhibition of resonance in case of boron. Okay. If you consider the steric inhibition of resonance, okay, then the order will be something like
1, 2, 3.
1, 2, 3.
3. Right. And there is no way of predicting it without knowing the pK values. Are you getting a point?
Yes,
Sir,
Yes, sir.
So, okay, I can suggest it for, because, yeah, that steric inhibition of resonance thing is there. But let me, consult some official sources.
sir,
Yeah.
there can be hydrogen bonding in one. Can there be?
Yeah, hydrogen bonding possibility is also there in one. So if the hydrogen bonding possibility is there, then it has to be in the plane. Then it has to suffer from plus some effect. Are you getting a point?
sure.
Okay, so then again it will go back to this, and I feel that this point is more legible. Are you getting a point? Because we considered it in case of orthohydroxybenzoic acid. Orthohydroxybenzoic acid is more acidic not because of SIR, it is because of hydrogen bonding. Are you getting a point? So
Yes.
here it
Yes,
has
sir.
to, at ortho position, it has to be, it is forced to be in the plane because actually it will form a 6-member ring. Let me try. Is it 6? Tell me.
So, but we go with other logic, means we'll get another answer.
No, but the thing is that, what might be prevailing is this one only. Because hydrogen, see, molecule will be preferring the hydrogen bonding stability. Are you getting a point?
Yes.
Because chelation actually leads to decrease in energy, and that stability is more compared to delocalization. Are you getting a point?
Yes, sir.
Okay, so I think, and if that is the case, then boron lone pair is permanently conjugated with the
Sir,
oxygen. Yeah.
sir, then
So
in
answer
this
should be
case,
1.
sir,
Yeah.
if hydrogen bonding is possible, then it should be less acidic, no, sir. Because it will not allow hydrogen to be lost.
So that is why I'm saying that the original answer is correct. Is it
Sir,
clear?
then it can be more less than 3 also, no, sir.
No, it won't be less than 3. See, due to hydrogen bonding, see here, yeah.
Sir, here between 1 and 3, if we compare we are
See,
comparing
plus M
by
effect
minus
is
I effect,
distance.
no, sir.
Sir, plus M effect is a distance independent effect. Are you getting
Yes,
a
sir.
point?
Yes.
So whether it is at ortho or para, it is same plus M. But the
Sir,
minus effect is disappearing at para position, almost.
sir, I mean, here we are like saying one is more acidic because of minus I is more, no sir. But
Yeah. Then 3.
but due to hydrogen bonding, like it cannot lose hydrogen that much easily as 3, no sir.
That is what my point is now. You are looking at the wrong atom. You are seeing acidic hydrogen. The acidity is due to the vacant lone pair of boron. Are you getting a point? Vacant orbital of boron.
Okay, sir. Okay, sir. Okay.
Okay,
Yes, sir.
you're looking at the wrong hydrogen. I am trying
sir.
to tell you this. Is it clear, all of you?
Yes,
Convinced?
sir.
Okay.
Yes, sir.
So it is, so best answer is this one only. Okay. So I think it should be, this should start. Okay, after this, 64.
64, sir.
Yeah, tell me, 64, what do you want?
The one greater.
Sir, in 2 and 3,
Yeah, what in 2 and 3? Tell me.
sir, in 2 there will be no conjugation itself, no sir. But in 3, though it is anti-aromatic, there is a possibility of conjugation. You said anti is more than no conjugation, no sir.
What did I say to you?
Aromatic is more than anti, no sir. Then
Aromatic.
non-aromatic, sir.
What have I said? When we come to stability, aromatic is more than non-aromatic, more than anti-aromatic.
Anti-aromatic.
Anti-aromatic becomes extra unstable because of this delocalization.
So we should not say conjugation in third one. We should say anti.
See, if
First
you
we
are
should
happy,
check aromaticity, sir.
you should check conjugation, then you should check aromaticity also. Okay, if it is anti-aromatic, it is automatically least stable. Is it clear?
Yes.
It's like you qualified IIT-JEE, but you didn't get 70% marks in the board. You're automatically disqualified. Is it clear?
Yes, sir.
Okay. Yeah. So once it is declared anti-aromatic, there is no one to listen to him. Okay. So after this, 61, 62, 63.
63.
Yeah, 63. Which one will be most acidic? So
3.
you want the whole order?
Yes, so once could you say the order?
Yeah, the order will be 3 will be most acidic. Then it will be meta 4. Then it will be 1, and then it will be 2.
So once could you say how we are comparing this?
See, this is minus M as well as minus I. This is at this position, it is creating positive charge due to minus I. There is no minus M at this position. This case, it is creating negative charge due to minus M greater than minus I plus I. Sorry, what am I doing?
Plus M, sir.
Plus M greater than minus I. And here there is no effect. So overall negative charge will be there because of OCS3. It's a powerful donating group. Okay. Is it clear?
Yes, sir.
So if that is done, then we can move to 61. No, there is no doubt. Tell me.
Sir, non-aromatic in the sense conjugated but not cyclic, or sir, totally not at all conjugated also includes.
Even if it is non-conjugated, it will be better than anti-aromatic. Getting a
Okay,
point?
sir.
Yeah.
Sir, once explain 61, sir.
61 is something which I have discussed in the class also. It is direct question on the notes. So the thing is that first you have to look at atomic factors, and then, so you see, if we are talking about basicity, carbon is greater than nitrogen, greater than oxygen. Right? This is sp3 carbon I am talking about. Yes?
Yes,
Basicity.
sir.
So obviously 2 will be greater than 3, and 3 will be greater than 1, 4. Yes or no?
Yes, sir.
Between 1 and 4. If the negative charge is delocalized in case of 4, it will be less basic. Getting a point?
Understood, sir.
Yeah. Such a relief. 60, 59.
No doubt, sir.
So 59.
Yeah, 59.
60, sir.
Yeah, 59. What is the doubt?
Second
Sir,
option.
Second option also
there
can
is
be,
no
sir.
methylene group only, no, sir.
See, first of all, I told you that alpha diketones are highly unstable. So here you are having alpha diketones. Even though you are
59.
59.
59, sir.
59, sir.
60 is clear, yes or no?
Yes, sir.
Sir.
Okay, 59, which does not have an active methylene group. Yeah,
Can be option 2.
Option
It
2,
can be
sir.
option 2 also.
It can be
sir.
option 2 also,
There
no,
is
sir.
no methylene group only, no, sir, in option 2.
Methylene group only.
I don't get the point.
So why can't option 2 be the answer, sir, in 59?
Yeah, because option 2, you see,
Electron
I
withdrawing
generate
group.
an electron
NO2 will stabilize.
between two electron withdrawing group. In this case, carbonyl is between NO2 and CH3. Where is the other end? Here, if some electron withdrawing group is there, then only no. Here, both sides you have electron withdrawing groups. In option 3, this is an electron withdrawing active methylene group.
What have means?
You are should be option
Sir,
3. This is an electron withdrawing active methylene group. Because if you have negative charge, you can replace here and here. Getting a point?
Sir, he's
Sir,
asking do
no,
not have,
option
right?
2.
option 2 does not have methylene group, no, sir.
Okay,
Yes,
what are they asking? 1 minute, 1 minute.
Not have.
Sir, electron withdrawing group is there means active methylene group.
Yes, sir.
Electron active methylene group.
Which don't have.
Second is not an electron active. Even 2 is the answer.
Yes.
You need groups on both sides. No.
Both
You see,
sides.
here, if you are, say, I am drawing it here. There is only single way resonance. In fact, you see, uh, it can only delocalize to this. It cannot go anywhere else.
Yes, sir.
Are you getting a point?
Sir, in option 4, though, like on both sides having
There's
conjugation,
no second
there's no
electron.
electron. Yeah, okay, sir.
Okay, you need 2 electron withdrawing groups for active methylene group.
Yes, sir.
Okay, on either side of the methylene group. Are you getting a point? So that negative
Yes,
charge
sir.
can be delocalized both sides. Okay,
Sir, option 2 is also correct because there is no methylene group, right?
yeah. Means, okay, we can say that also. Okay, 2 is, okay, 59 is going for, definitely going for a change. Okay, after that, 57, 58.
No doubt, sir.
Okay,
Sir,
yeah.
in
Tell.
57, first option can get, means we can do conjugation and we can get OH group, no, sir.
Alpha.
Okay, this is a question which I have actually given in the notes. Okay, there is no sp3 alpha hydrogen to the conjugated system. Is there any sp3 alpha hydrogen?
No, sir.
Then there cannot be anything. Is it clear? sp2 lone pair cannot be delocalized. So that is why. In this case, you have an sp3 alpha hydrogen here, here, and here. This is the conjugate, this is the alpha hydrogen. Is it clear?
Yes, sir.
Okay, moving forward, 54, 55, 56. This is also
Can you explain
discussed.
54?
Huh? 55. 55 is a doubt. See, negative charge is less stable on an sp3 carbon, so it will be more basic. Okay, but I think that, yeah, NH2 minus is more basic than this because negative charge is more stable on the more electronegative sp carbon compared to nitrogen. Is it clear? Okay, so I think we can safely go to
53, sir.
53. Okay, which of the facts explain why p-nitrophenol is more acidic than phenol? Okay, so p-nitrophenol is something like this. There is no shortage of space.
Okay, sir. No doubt, sir.
Okay.
52,
So
sir.
1, 2, 3 is not there. Okay, 52. Most acidic hydrogen, sp carbon negative charge will be more stable.
So it can be option 2, no, sir.
Option 2, sp charge is coming on. See, negative charge is not directly coming to the sp carbon. No. Are you getting a point? That's
Yes,
right.
sir.
So answer should be 3 only.
Sir,
Of
time, sir, 50 seconds.
50 seconds, yeah. Again explain.
Yeah, once again, could you repeat?
See, in this case, 100% of the time it is handled by the more electronegative atom. Here only 50% time it is handled by, most of the time it is handled by sp3. Only 50, sometime it is handled by this if you are doing resonance also. Atomic factors dominate over delocalization factors. Are you getting a point?
Yes, sir.
If negative charge can be carried by a more competent or more electronegative atom, it will carry it. It will be preferred there. Is it clear?
Yes, sir, understood.
Okay. So I
Sir,
believe that,
56 option 1.
okay, so it is option 1. Tautomerism cannot be exhibited by, how will you, there's no
Will,
pi one, no?
will be.
How will
Will
you,
be
Will be exhibited.
huh?
Tautomerism will be exhibited by.
Okay, will be, you know. Yeah, so 1 will not exhibit tautomerism, no? You are asking how 4 will exhibit, right? Is nitro Ac nitro?
Option 1, sir.
Option 1 cannot exhibit tautomerism, no. How will it exhibit tautomerism? There is no pi bond. Where do you want to delocalize it? Then is it possible? Yes, no?
No,
I'm not
sir.
able to see it.
Understood,
You
sir.
need at least a pi bond, no? Keto, enol, all are having a pi bond. Tautomerism requires a pi bond. Then only it can move. Okay.
Okay.
Then what
So
about option 2?
option 2. Yeah, option 2 does not have any sp3 hydrogen. That's why. 1 minute. Yeah. Is it clear?
The third option.
Yeah, you lost all the 3. Okay. Third is again the same thing. There is no alpha hydrogen. If this is hydrogen, then this will go here, and this will go here, and this will go here. Is it clear?
Without CH3.
Huh?
Understood, sir.
Okay. So I think with this we can formally end the paper discussion. Okay, just little. So I'm pausing the recording now. Okay. Yeah. So now we are live, and today we are going to start paper discussion for WTA 19, and this is a paper which is based on your GOC, acids and bases, and tautomerism. Okay. So the first section is integer type question. Okay, where it is the answer is a single digit integer. So 21, 22.
So 22.
21 is not a doubt.
No, sir.
21 which can show. Let me just check. 21 they are asking 3. So I think this will show. This will show.
The answer must be 4, 3 only, sir.
Huh?
Nothing, sir.
22. Answer should be F and G. You see, you should have an alpha sp3 hydrogen to a conjugated system. Are you getting a point? So you see, this is the conjugated sp2 hydrogen. This is the okay.
G
One
and
minute.
H, yes, sir.
You are having no.
D.
1 minute. Let me check. Okay. See, G will be there because at alpha sp3 carbon, There is no hydrogen. These are the
Beige.
alpha sp3 carbon to the conjugated system. Here you are having at alpha sp3 carbon is this, these two are having hydrogen. So here tautomerism will be possible. Okay, what are you saying? D.
Yes,
Yeah,
sir.
in D also it is. So answer should be D and G only. Do you have any other choice?
No, sir.
No, sir.
Okay, then it is good enough. D and G. Okay, 22 is clear to all of you? Answer will be D and G.
Yes, sir.
Okay, let us first discuss chemistry and then we'll talk about marks. Okay, because marks are temporary, chemistry is permanent. Okay, 22 is done. 21, there is no doubt. I think we have discussed this concept multiple times. Alpha sp3 hydrogen to a conjugated system. Okay, if it is there, it will show tautomerism. Is it clear? Okay, now after this, 23, 24. Any doubt? Here, less keto content, less enol content than keto. Okay,
Not
is it clear?
Sir,
Then only this, option?
4, 23rd one.
Yeah, option 4, see, I have told you this thing, that enol will be more stable than keto only in two cases. First, when you are having intermolecular hydrogen bonding, and
aromatics.
second, you are having aromatic stabilization. If both are not there, there is no such thing. Is it clear?
Yes, sir.
Yes,
The
sir.
two A and C are having aromatic stabilization, so it will be correct. Okay. 24,
No doubt, sir.
no doubt. This we have discussed. 25, 25, there is no meaning of X, like
X.
all are phenol derivatives because they are containing an OH group. Okay. Number of phenol derivatives which give the positive test with NaSCO3. I have told you all monophenol derivatives will not give sodium bicarbonate test. If you have di-substituted phenols with electron withdrawing groups or tri-substituted phenol, then only it will give. So only these two are the candidates for giving the NaSCO3 test. So Y will be 2.
Sir,
X will be 6.
electron withdrawing groups plus di or tri-substituted.
Di-substituted or tri-substituted phenols with electron withdrawing groups. Are you getting a point?
Yes, sir.
Then it will give. So this, you can remember it as a, this generally works for most of the cases. Okay. If there is an exception, we will look into it. But till now, I have not seen any exception to this. Although this is not any official rule, that is totally based on my experience. Okay. 26.
Sir,
Is it,
F, sir.
Yeah, 26. You see, answer should be F. A, C, E, and F. I think A, C, and E should be clear to you. All carboxylic acids will give, and all dinitrophenols will give.
Yes, sir.
F is something which we have to look into. So you see, you can write F like this. Okay. Although I need to, if I can find a source, I'll be very happy. But if you see squaric acid, so this is a aromatic system. Are you getting a point?
Yes, sir.
Okay. So even if it loses an O minus, see, like I think you discussed squaric acid.
Squaric acid.
Okay.
Yes.
It is similar to that only. Can you get this thing? So it is having very high pK value, almost very high acidity or very low pK value. Is it clear? Yes or no?
Yes, sir.
Yes, sir.
So that is why F is having very high acidity. So it will obviously show the sodium bicarbonate test. Okay, you see sodium H2CO3 is having pKa value of approximately 6 to 6.5, I guess. So anything low than less pK will be giving the test. Are you getting a point? In case you have any confusion in any of the compounds, you can directly check the pK values. Are you getting a point?
Sir, what is pKa value of ethane?
It is high. It's something like 10 power. It's like 15 or something like that. Are you getting a point? Let me just check pK. pK of ethane. pKa ethane. Yeah, pK of ethane is 25, not 15. It's 25. Are you getting a point? Water is having a pK of, I think, 16 or 18, something like 16, I think. So ethane is less acidic than water. pK of water. pK of water is 15.7. Okay. Means most of the alcohols will have pK values in 16 or 17, 18. Getting my point? So ethane is even less, what do you say, acidic than alcohol. Is it clear?
Yes, sir.
Yes, sir.
Okay. You should have some idea of the values, not mugging up all the values, but some idea you should be having. So you see pK of water is 15.7. Okay. All substances which are having pK less are considered to be acids. Are you getting a point?
Yes, sir.
Okay. And so that is the case. After this, 27, 28.
Explain, sir. 27.
See, they are just considering all the acids in these cases. All substances which are having pK, means which are acidic, will be counted. Phenols are also acidic in nature because pK is less than 15.7. Are you getting a point? So only this is not having because it is having negative charge on carbon.
Sir,
Yeah.
phenols
Sir, though
are
it is-
less acidic than water, no?
Phenol is more acidic than water
Yes, sir.
because negative charge is
Yes, sir.
delocalized now.
Yes,
Are
sir.
you getting a point? pK is 10. I have given for phenol pK is 10 to 11, I think.
Yes, sir.
Okay. So
Sir,
that is,
though phenol is attached with the electron donating group, it will be acidic itself.
yeah. See, electronic factors will cause minor variation in acidity. Are you getting a point? It will not push it very less acidic. Are you getting a point? Again, this is something which has to be confirmed with the values. But I think if you are having even para-methoxyphenol, it won't be having it will be having pK something between 11 and 12, not more than that. Water is having a pK of 15.7. It's definitely more acidic than water, no? If it is acidic than water, then it will react with OH minus. Is it clear? Yes or no?
Sir,
Yeah.
for this 27th question, we should do based on pK values only, or like
Yeah. Obviously, you have to just identify all the acids, all the acidic hydrogens you have to mark. So this hydrogen is not acidic, no? We have discussed this. Or
Yes.
any hydrogen which is connected to oxygen or any electronegative atom is acidic. So basically, they are asking all the acidic hydrogens. Okay.
yes, sir.
So hydrogen connected, which is connected to oxygen. Okay. So if hydrogen is connected to oxygen, it will be more acidic than water. Are you getting a point? Yes
Yes,
or no?
sir.
Okay. So only A is not answered. 28. Again, you have to see all the acidic hydrogens in this case. Okay. So except A and F, all will be the answer. Getting a point?
Yes, sir.
Yes, sir.
Yes, sir.
After that, 29, 30, 31, 32.
So 32.
So 32.
32. Which are stronger acids than ethyl alcohol. So ethyl alcohol is something like this. Okay. So stronger acid than ethyl alcohol. So if you are having what is this electron withdrawing group, then it will stabilize the anion more. No? Are you getting
Sir, in B, it is a bit far, no, sir.
Sir, here
See, something is better than nothing. No. If you have an electron withdrawing group, it is better than having no electron withdrawing group at all.
electron donating group is also there, no, sir.
Where?
CH3 is also.
Yeah, but fluorine is having very powerful minus I effect. CH3 is actually is the part of the alkyl chain in this case.
Includes.
Okay.
Sir, but if we compare with ethyl alcohol, it is having one extra methyl group, no, sir. So
But it is having fluorine also now. Overall
how
thing is happening is will be stabilizing only the negative charge. Okay.
yes, sir.
Overall thing will be stabilizing the negative charge. So answer should be A, B, C. All electron withdrawing groups. That is the purpose of asking the question. Nothing else. Okay.
Sir, that means these all electron withdrawing groups will be dominating over CH3.
Yes, yes,
Donate.
yes, yes, yes. See, when it comes to carbocations, then only CH3 can show plus H effect. Are you getting a point? And that then only it can be strongly electron with donating group. But when it comes to carbanions or any type of anions, then CH3 can only show plus I effect. It cannot show plus H effect. Are you getting a point?
As plus I is weaker, it will not
Yes.
affect much.
Yes.
Okay, sir.
Plus I of CH3 is much weaker compared to minus I of fluorine or cyanide for that matter. Is it clear? Yes or no?
Yes.
Okay.
So 30,
Yeah.
31st one, sir.
31st. Stronger bases than ammonia. I think I have given this, not 213. Okay, so all are CH3. So all are
Yes, sir.
the order is 213 ammonia.
Yes, sir.
So and aniline is weaker base because you are having nitrogen lone pair delocalized. That's why. Is it clear? I have given this point that first thing you have to look is delocalization of nitrogen lone pair.
Yes, sir.
Okay, that's it. Okay, after this 33, 34,
So
30,
option 2.
33, option A.
Option 2, sir. Second option.
This one.
Second option is
This. A, B, C, D, which one?
second option, sir. B.
Yeah, it will show tautomerism, no? Alpha hydrogen.
Nice, sir. Yes, I will observe that.
Is it clear? Here also alpha hydrogen, alpha hydrogen. 34, 35,
35.
Option C.
35, sir.
34 is it out?
35.
35, sir.
35.
Option C, sir.
35 option C is an active methylene group, no?
Option A, sir.
Option
Yes,
A,
sir. A.
it is asking which one will having lesser enol content, no? So you see, this is having no cross conjugation. Are you getting a point? It is only destabilizing through plus R, but it is having active methylene group here. All others are also having active methylene group. On this only if there is no destabilization, this will have higher enol content. Are you getting a point? Yes or no? Because perfectly no destabilization is there. In all other cases, you have cross conjugation in B and C, and D it is single ketone, so obviously less enol content. Are you getting a point?
Yes, sir.
Yes, sir.
Everyone is getting? Okay. 34 is not it out?
No.
Alpha
sir.
sp3 hydrogen. Yeah,
No.
we have discussed enough questions on this. 36.
No, sir.
Okay. 37, 38.
No, sir.
No, sir.
That's awesome. And 39, 40. Just
No,
chemistry
sir.
part.
No, sir.
No doubts. Okay. So I can say that the paper discussion for this test is, this paper is done. Last time, any doubt in any of the questions we can discuss. Just go through the whole paper and see if you have any doubts pending. We can discuss it. I'm giving you 1 minute to see through the whole paper. Okay, I am just going through the first page again. 21, 22, 23, 24. Yeah.
So in the questions like 25 and 26.
Yeah, tell me.
Not 25, so 26 or 27.
26.
So in this kind of questions, we should just check for acidity, which is
I have told you there are two ways of solving this question, two parameters. First, when you're talking a sodium bicarbonate test, only see the real parameter is that the pK value should be less than 6.5. Okay, but suppose we don't know that, then there are multiple ways. First, all carboxylic acids will give, all
Yes, sir.
monophenols not give. Say third, di or tri electron withdrawing group phenols give. Getting a point? Post aromatic anions, okay, will give with negative charge on oxygen. Are you getting a point? This is an important point.
yes, sir.
Is it clear? I think this will cover almost every case which is there in the market. Is it
Can
clear?
you scroll down?
Sir, if it is like AgNO3 test or something, then what are the steps? Like
AgNO3 test, there is only one thing, that the carbocation should be stable.
Stable.
Okay. If it is stable, then Cl minus will leave, you will get precipitate easily. So remember that 2 degree, 1 degree, these will not give. Are you getting a point? At least you should be starting with 3 degree and benzyl. Is it clear?
yes, sir.
Okay.
Sir,
Yeah.
criteria for NaOH and sodium.
See, sodium test. Okay. Where is this? Oh, okay.
28.
Yeah, just. Yeah. Now, when you're talking a sodium hydroxide test, given by all acids, which are more acid, less acidic than water. See, the definition of acid is which is having more H plus giving tendency than water. Are you getting a point?
Yes, sir.
This means pK should be less than 15.7. Okay. So NaOH test will be given by all phenols. Okay. All carboxylic acids. Okay. All okay. That's it. Okay, I don't know about cyclopentadiene. Let me check once.
Sir, generally alkenes will give NaOH test or not?
No.
cycloalkenes.
The negative charge, okay, negative charge should be on, one way of looking is anions having negative charge on
Electronegative.
oxygen. Okay, not electron, on oxygen, that will be more acidic than water. Are you getting a point?
Yes,
Sir,
sir.
alkynes will give.
No.
Sir?
Oh.
Sir, now anions having negative charge on oxygen will be more acidic than H2O, you're saying?
Yes.
Okay.
So even cyclopentadiene is a case which won't give. Are you getting a point? Cyclopentadiene is having a pK of 16. It won't give.
Sir, is there any such compound like dialkene, cyclodialkene?
No, active methylene group will give. Are you getting a point? All
Sir,
active,
any cyclodialkene will not give us.
Which this is forming an aromatic anion, but it is still not giving. So this means that solely negative charge on carbon without any extra stabilization won't be given. In this case, if you get negative charge, it gets delocalized straight to oxygen. So again, the negative charge is coming on oxygen, so it is giving. So all active methylene compounds will give NaH test. Are you getting the point? In fact, most of them will also give like NaHCO3 test also. Are you getting a point?
Yes.
If there is no cross conjugation.
So sodium metal.
Sodium metal test is given by all acidic hydrogens. I think I've given you the criteria for acidic hydrogen in Grignard reagent.
Yes, sir.
So I think
Sir, why alkynes do not give?
alkynes will give sodium metal test.
Yes, sir.
Alkenes won't give sodium metal test. Alkynes, sp carbon is electronegative enough to hold a negative charge. Is it clear?
Yes, sir.
Yes, sir.
Okay. 28 is done. Any other doubt?
Sir, 30 option 1.
30 option 1. It is asking more basic than. So this is aromatically delocalized. This is delocalized, but it's not aromatic delocalization. In fact, delocalization of this lone pair disturbs the aromaticity of the ring. But here it is seamlessly, delocalized. Is it clear? Delocalization of lone pair decreases basicity. Aromatic delocalization decreases it even more. Is it clear? Yes or no?
Sir, once again, can you say?
I am saying that delocalization of lone pair decreases basicity. Aromatic delocalization of lone pair decreases it to maximum extent. Getting my point?
Yes, sir.
So this is very, very delocalized. So very, very less basic. Okay? Other than that?
Sir?
Yeah, tell me.
Other than this NaOH, AgNO3, is there any other common test like which will be asked frequently?
It's like, see, tests are there, okay. But right now, the things which you have studied, okay, based on those, whatever tests are there, we have already discussed. Other tests like, you have tolerance test, you have Felling's test, you have haloform reaction. These things will come in coming chapters. We'll be discussing it with the chapter itself. Is it clear? You have the Lucas test also. Okay. So let it, you can't go through all the tests at once. Is it clear? Okay. As it comes, we'll discuss.
Yes, sir. Okay, sir.
See, remember one thing. Okay. See that if you get a new question, it is good for you. Okay. Even if you are losing marks right now, you won't lose that marks in future. Are you getting a point?
Yes, sir.
So don't be afraid or scared that you got a question which was not covered. Okay, then you got a chance now to see it right now. Okay, and you see, second thing is that you cannot know everything in chemistry. Are you getting me? It is a huge subject, and questions can be framed from any part. My approach, I have told you always that it should be, you should be able to attempt and get 90 to 90% of the questions correctly. 10% would always be there where you will be learning something new. I have been studying chemistry for last, then now to since ITJ I gave in 2005. It has been 15 years. Still, sometimes I get something new. Okay, so that 10% should be there. Then only you will be interested in the subject. Now. If you know everything, then so you lose interest. Are you getting a point? You should be happy that there is something which is new to you. And most of the people, you see, if you are doing 80% plus in any paper, you are doing more than good. Are you getting a point? If you are able to maintain that performance in ITJ, you'll be in the top 50 in the whole country in chemistry. 132 was the paper this time. Anyone who has gotten more than 105 definitely will be in top 50 in this whole country. But people are not able to get that much, I'm telling you.
So why is it? What is the reason?
Because when the whole, what you say as, when the whole syllabus comes, okay, everything comes, then it's the consolidation which is the toughest part of this preparation. Knowing things, going in depth is not the toughest part. It's the consolidation of whatever you have learned over these 1.5 years in the teaching phase. That has to be consolidated, and that experience has to be carried out on the final day. Are you getting my point? If you are able to even carry out 70% of what you are currently in each and every topic which you are doing right now, you will surely be, in top 500. No one can give you a better guarantee than this. Are you getting my point? Because under top 500, it depends on that very day who is in top 100. Are you getting a point?
Yes, sir.
So that we will take care in the revision phase. But right now, the papers which you are getting, you are able to do? Yes or no? There can be some anomalies, but mostly the paper you are able to do easily, right?
Yes, sir. But when there's no partial marking, like we are.
Yeah. Now let me first, stop the recording. Okay.